This episode is brought to you by Brilliant. There is a school of thought that says our bodies are little more than a vehicle and life support system for our brains. If that's true, we might be able to transplant the brain into some much cooler vehicles. One of the more popular notions in science fiction is the idea that you might separate a person's head from their body and keep it alive, or even just their brain. And today we'll be looking at this idea, how it differs in form, function, and implications from a digital copy of a mind uploading, and what reasons and motivation we have for doing this, such as life extension, extreme emergency medicine, resource scarcity, or even punishment. This is going to be one of our more food for thought fun episodes, but as we'll see today, it's not likely to be something we only see in sci-fi. It's actually quite plausible we'll see this option used in the future, especially if digitally copying minds turns out to be harder than we expect, or even practically impossible. Speaking of food for thought, you might want to grab a drink and a snack, and hit the like button while you're at it. The idea of brains in jars has mostly fallen into the realm of more humorous science fiction like Futurama, in favor of the notion of mind uploading, which tends to seem the better option, and we'll discuss why in a bit. But it is worth remembering, these are very different technologies, and in truth we'll probably be able to keep a brain alive in a tank a lot sooner before we could emulate a brain on a computer. The other thing about mind uploading is that it's not just trying to emulate human neurons and tie them all together to replicate a human's mind. It's trying to exactly copy a specific person's brain, which is going to be a good deal trickier, as you're not trying to achieve a good likeness, but rather an exact one. This is where we've tended to let fiction and notions about technology run a bit away with us. There are many reasons you might copy a human mind, but the big one is usually to make an immortal version of a person that you can digitally back up. If the copy is right, then that person is preserved, but the original has simply been copied, and the original is still sitting there in the brain scanner afterward, unless for some reason the scanning process was inherently destructive or lethal. Which is a nice hand wave in fiction to remove the original person from consideration, but not a very likely one, that the scanning method would just coincidentally need to vaporize the original. All the more so since we're not likely to ever be encouraging research on brain scanning that tended to vaporize brains. You have intermediate steps of technologies, and I'm not really sure how a partial brain scanner that vaporized neurons during the process would be seen as useful to encourage further research and funding. So even if a destructive scanning method just happened to be a bit easier than a non-destructive one, it would probably lag behind in research efforts to any non-destructive scanning approaches. That's assuming we continue to practice mostly ethical medical science in ways that respect basic human rights. Of course, you could also experiment on non-human subjects or volunteers who donated their bodies to science, and that is an example of where such a destructive scanner avoids the problem of copying or killing the original brain, as the person is already dead or dying. But even that has a problem, because if you start telling folks you want to vaporize their brain to research how to digitally resurrect other folks, most would probably say, hey, wait a minute, why don't I just get my brain frozen instead, till you perfect the technique and can copy me? And of course we can already do this, albeit with extreme tissue damage at the moment. But in terms of cost, it's not much more expensive to freeze someone's head than usual funeral costs or many common life-saving procedures, and mostly just because we don't do it much and a lot of the money goes into researching better preservation and resurrection techniques. In terms of raw costs, there's not much difference between a casket and a cryonic cask or duo, especially when only big enough for a head. It's certainly not a space and maintenance issue either. Cemeteries take up a lot of space and aren't cheap to maintain, whereas you could stick 100 frozen heads or brains into a single cubic meter. As to keeping them frozen, liquid nitrogen costs approximately as much per volume as milk, and a decent duo only needs refilling a few times a year, less if you had tons of them in storage together, and so preserving a brain might be less than $1 a year in terms of the nitrogen. This isn't an episode on cryonics or cryogenics, but it needs to be kept in mind because if we do perfect ways of freezing a brain that are solidly non-destructive, which we can't with current methods, that leaves the door open to scanning or thawing that brain out one day with better technology, and you presumably see a very big uptick in folks choosing this. If you're curious, we could probably store dozens of generations of brains on ice for centuries, without it being any sort of significant drain on the economy, especially if it were done so frequently that it would create an economy of scale for brain removal and tank production and maintenance. We don't know which we'd be able to do first, thaw a brain and stick it in a clone or android body, or scan a brain, but even if we could do both, a lot of folks would presumably prefer their original brain over a digital one. We often used to consider keeping the brain in a jar a method of life extension once the body fell apart, but brains age too. A digital copy can be maintained indefinitely by having backups and using existing data integrity methods. However, we should keep in mind that if you actually have the sorts of technologies needed for brain scanning, which is as likely to be billions of nanobots running around your brain, imaging each neuron, as some super MRI scanning it externally, that tends to imply you can repair or build neurons too. Those of us already acquainted with the whole copying issue often suggest a gradual neuron by neuron copy and replace with artificial neurons, little machines emulating an individual neuron and replacing an existing one. But you could presumably just set them up to constantly repair and replace with regular neurons just as easily. It might require more maintenance, but it's the same maintenance your body already does unaided anyway, and neurons have much longer lifetimes than most cells, though it depends on which type of neuron is under discussion and we have multiple types. Needless to say, brain cells can be damaged and decay too, as any number of mental conditions associated with aging show us. Indeed, that's a lot of why the brain in a jar is an attractive idea. Brain cells might not be able to live indefinitely, but they at least have a lot more longevity than the body as a whole does. So if we never get practical medical technology able to repair every single cell, the brain in a jar method might be a life extension method we'd use. Also, if you can copy a frozen brain onto a hard drive, there's no particular reason to think it would be much harder to print a new brain either. The level of intricacy and technology ought to be parallel, so scanning a brain to duplicate it onto a newly printed organic brain as opposed to a hard drive ought to be viable for those who prefer that. Neurons vary wildly in size and type, but the average in your brain would be about 10 nanograms, which isn't much but does mean they're each composed of trillions of atoms, so we probably grow various types of generic grown neurons and use them in an advanced 3D printer a long time before we could be doing precision atomic printing. It's also a reminder that the brain isn't really atomic scale, though that is debatable in regard to the information storage on it. Still, we probably don't need to be duplicating with atomic precision to properly replicate the same neuron for all practical purposes, like memory, and of course they are constantly having new atoms added and old ones removed too. Those neurons need life support same as any other cell, and are not identical to what they were yesterday or 10 years from now, even if the neuron itself has kept going. Key notion is that there's a lot of technical difficulties involved in preserving or copying our brains, be it organically or digitally, and we have no idea which would be easiest or most effective. But even if one method is easier, it doesn't mean it's the one folks would prefer. So if you have multiple methods that are doable and aren't wildly different in effective cost and upkeep, folks would presumably pick the one they liked. But a brain in a jar is not necessarily just your brain as is, placed in a jar. Once we've got a brain out of a skull, it could potentially be modified or grown larger, which is another point too. A lot of the damage we get, or life support issues for the brain we have, revolve around things like radiation and contamination. And if you got a brain in some big radiation shielded vessel with strict control of the nutrients going in, like no potassium radioisotopes, just the non-radioactive kind, or very refined chemicals to remove toxins and impurities, you probably can keep that brain running a lot longer. And while it is changing with time, both in contents and makeup, it is the same type of change we already undergo, which might be more appealing for some folks. You also presumably can't easily hack or alter it, in a computer sense. Obviously you can hack it in a more traditional way, but it is presumably much harder to smash a brain in some armored support vat than a classic skull, or the body supporting it. I'm not sure why the brain in a jar or vat is always shown as a fragile looking glass, but presumably that's just the artist trying to make its contents obvious. Your brain is already heavily armored compared to most of your body, and if you're removing it from the body and skull, you are presumably putting in something a bit more solid than a glass mason jar. Of course, we sometimes see them with the spine or eyeballs still attached, and a nice window certainly is helpful in that case, though it is a reminder that our mind is not just our brain. There's no non-arbitrary border to your mind really. Yes, the skull is where the brain is kept, but that's not really the whole of your actual mind from a thinking perspective. You've got that nervous system throughout your body plus all those hormones produced by this or that gland. Those presumably can be replicated by having small tanks of artificial hormones, or machines that produce them, injecting them into the brain along with the normal blood and oxygen. Still, we probably shouldn't assume someone who wants to preserve their brain would automatically be fine with synthetics, and if not require a whole body. Some folks might draw their lines at different places on what they preferred, so you might have various glands in the nutrient bath too. Incidentally, we're just sticking with the trope of a brain in a nutrient bath for simplicity's sake, though cerebrospinal fluid is indeed clear and colorless. We also have successfully removed pig brains from their bodies and kept them alive, though not thinking or really experiencing thus far, and we've had limited success with things like brain and head transplants and connecting neurons to mind-machine interfaces, though needless to say, success thus far has been modest and debatable, but techniques are improving. The concept though is not limited to simply a brain being removed, but more the idea of removing all but the most vital components needed to keep a person alive. Science and experimentation will help us figure out what that actually is, and we will doubtless get that experience because folks will often end up badly injured but with their brain intact, as is a small part of your body that might get missed by damage and is heavily armored. While it's neat to contemplate options like brain scans and nanobot repairs, they are still quite a ways off, and mostly not much of interest to the public when it comes to funding and attracting professionals, whereas we have plenty of folks who get gravely injured and might be able to live with those emerging technologies or have their life quality improved by them. So we'll probably discover sooner than later what we need to keep a person alive, and not necessarily in control of some sort of cloned or android body, by which I don't just mean an alternative like some giant mecha or war robot or an inhuman form, like having your brain grafted into an animal or alien or a spaceship as a body. We might keep a brain simply in a deep slumber state or dreaming. As mentioned, those initial big brain removals kept the brain alive, but with little to no activity, so it might be, given that neurons live far longer than most cells, that this approach of suspended or low activity thinking might become a more practical alternative than freezing brains, which damages stuff. Or it could be done for experimentation or as a punishment, keeping folks conscious, in sensory deprivation, or feeding them fake stimuli. This latter notion is the basis of the brain in a vat thought problem, which people tend to assume is identical to the situation we'd be dealing with in examples of digitally uploaded or simulated minds. One big difference between those is that with a digital mind, uploaded or simulated, not only do you control all the sensory input that mind experiences, but you can pause your simulation or edit that mind or revert to an auto-save state or copy if you make an error that gives the fake reality away. You probably could technically do that with an actual meat brain too. The line between organic and artificial or mechanized gets hazy to the point of irrelevance with sufficient technology, but for the moment we'll assume all you control in a brain in a vat is the sensory inputs, and of course the ability to shut it off permanently. What is the actual brain in a vat thought experiment though? It's essentially a modernized version of Plato's allegory of the cave and Descartes' meditations on first principles, such as I think therefore I am. Same basic principles involved as in simulation-based thought experiments, but again differing in that the programmer is not limited to sensory control of the person's mind. They can edit that too, whereas the mad scientist with the brain in the vat can't. As we've discussed in episodes on that topic before, like simulation hypothesis, reality and simulation, and virtual worlds, my own opinion is that this tendency to try to delineate the real world from the fake one is often not really a productive line of discussion. It just leads to solipsism and hinges on an arguably false dichotomy. Defining something as unreal because it's artificial is a pretty dubious notion. It might be a bit semantic to say that living in a house whose architecture and decor you've selected, and somebody else did, isn't really much different than living in a virtual environment you or someone else made, and really seems to hinge more on the notion of not if the reality you are in is created, but rather if your existence in it is deceptive. And that's more about truth and free will than reality. As an example, we have theories that suggest black holes might spawn new universes when they form, essentially making those a reality beneath our own, but also implying we might have been spawned by the Big Bang as a product of a black hole forming in an order universe. I'm not sure how that would make us less real than the folks living in that universe, or more real than one spawned by formation of a black hole in our universe, or how any of that differs from a simulated universe beyond the implied artificial origin via a programmer or creator. That brain in a vat might exist as a separate and real thing in the universe that's running the simulations it experiences, but so too would a hard drive, and presumably for that black hole example, that black hole in an order universe. Let's say our technology allowed us to rescue folks who were severely injured by placing their brains in vats, and we lacked good android technology, so we stuck them in a simulated village and told them that was the case, and that they could call their friends and family in the outside world, and that they had control of that environment within the limits of their group decisions and the software's limitations. That suddenly seems a lot less sinister and philosophically interesting than the normal brain of that, and I'm not really sure how that place is any different than a remote village on Earth that's cut off from most external contact beyond telephone and internet. You can't know if the reality you're in is the one and only real place, and I'm not sure that it matters in and of itself, as opposed to the question of if you're in there voluntarily, or aware of your circumstances, or if the folks controlling it are good or evil. Sometimes the better question isn't if what you experience is real or not, or how you know, but if it actually matters. When it comes to what life would be like as a brain in a jar, much like a digitally uploaded mind, and depending on your technology, it might be identical to normal life. Indeed, with the right technology, it might be identical to being digitally uploaded. You can mess with the brain like you can a computer file with enough tech, altering or reversing memory inputs in the meat of the brain, but we shouldn't assume a programmer could casually screw with a digital mind, which is likely to be a very complex and sensitive thing that might be severely damaged by minor edits, especially if it's just an emulation of a meat brain. You could have a case where that brain is just an android body, which is arguably just a cyborg. It might have cybernetic enhancements to the mind too, or have genetic tweaking to allow it to grow bigger. Classic sci-fi is full of giant-headed aliens with highly evolved giant brains, and while newer stuff tends to focus more on the digital, this augmented approach might turn out to be a more preferred route for transhumanism or posthumanism, since it doesn't involve copying your brain onto a hard drive or necessarily adding mechanical or electronic components to the actual brain itself, just the sensory and life support bits. And there's a good chance this pathway will be available to us a lot sooner than all the digital options, which I sometimes think only seem more probable by embracing a handwave that mind uploading is really just about having a ton of computational power and a very good brain scanner. So what are your options for life as a brain in a jar? Well, if you're not tinkering with a basic brain much, you probably need an android body or a simulated one in virtual reality that's very human in function and inputs. But even assuming we can't tinker much with the actual brain to allow it to comfortably run in human forms, the brain itself is very adaptive, so folks might be able to adjust to running something more animal or vehicle-like instead of human form. Personally, I'm very fond of the notion of being a giant human mecha, with Gatling guns and missile racks. But the neat thing is you could transplant the brain to other bodies, whether by moving the brain jar or just by doing everything by telepresence, with the brain in some nice armored bunker somewhere. The other aspect is that it might become a preferred thing for civilizations. Bodies take a lot of calories to run, and brains are big users of that, chewing up around 15% of most folks' calories, while making up only around 2% of their body mass. So unlike digital minds, which might run thousands or millions of times more efficiently than human brains, these would only let you get maybe 6 times as many people for the same amount of food as normal folks like you and I eat. Still, it is 6 times as many, which is nothing to sneeze at if your civilization wants to maximize its population. And there's a couple of caveats too. First, it's only theoretical that we can make hyper-efficient computers. We have made some supercomputers that match our best guess for a human's analogy of processing power, but those things are power and heat gluttons, sucking out many thousands of times more power than a human brain does. We probably can do way better in the future than our meat brains in terms of power for computation, but shouldn't just take that for granted and assume we'll eventually hit some super high efficiency rate. And that only matters if folks feel a digital mind is equal or better than going brain in a jar. Second, our brains use about 16 watts of power to run, but that does not mean that needs to come from food grown on open land or in hydroponic farms. Once you've abandoned the flesh in favor of synthetic sensory input, worrying about things like taste and dietary fiber and texture start being rather irrelevant. You do not have an actual tongue or stomach after all. None of the stuff our cells run on, be it normal cells or neurons, really requires a plant grown under sunlight to make food we eat directly or further up the food chain. There's lots of things you need to feed the brain, but the big ones are glucose and oxygen, and either could be introduced into blood via synthetic production like photovoltaics, which is way more efficient than photosynthesis. If we just assumed we could only achieve a 10% efficiency of photovoltaic sunlight capture to glucose energy, you still wouldn't need a solar panel much bigger than the jaw for the brain to keep it running, and you could have a planet-wide brain farm running on solar containing over a quadrillion people. Nor would that necessarily need to be on Earth either. Obviously, we could use our usual notion of rotating habitats, but brains in a jar might not actually need gravity, and if they did, probably would be fine in a relatively small centrifuge, since it probably would only need low gravity, and even if you didn't, you can probably ignore most of the vertigo and nausea issues associated to high RPM rotation, what with the lack of natural ears and such. In such a case, a Dyson swarm created around this purpose, somewhat akin to a Matryoshka brain, allows far more people than a regular Dyson swarm. Those usually permit around 1 billion times more people than could live on Earth and are very raw material intensive, requiring the disassembly of an entire solar system or more, something we'll look at more next week. Alternatively, a brain jar Dyson swarm, using the 10% efficiency we suggested a moment ago, could house 2.4 trillion people, or brains, and probably would only need about an Earth's worth of raw materials to construct. I'm not sure many folks would find that appealing, but it might be entirely fine with folks if it was accompanied with virtual worlds and telepresence and allowed thousands of times more folks to live and enjoy such places. Indeed, they might find it a better and safer and longer-lived alternative. I'm not sure it would be my cup of tea, but as I said earlier, while continuing as I am is my current preference, the notion of stalking around the landscape as a brain inside a giant robot has a lot of appeal. We were talking a lot today about brains versus artificial intelligence or mind uploading, and if you'd like to learn more about concepts like neural networks or computational biology, there are some fantastic courses on those topics over at Brilliant. To truly understand the human mind, or to devise artificial intelligence, we'll need to develop a deep understanding of neural nets, and they are a growing field in academics and business, and Brilliant's focus on fun and interactive methods makes them a great choice for learning about this topic or many others. Whether you're a student, a parent trying to enhance your kid's education, a professional brushing up on cutting-edge topics, or someone who just wants to use this time to understand the world better, you should check out Brilliant. Try adding some learning structure to your day by setting a goal to improve yourself, and then work at that goal just a little bit every day. Brilliant makes that possible with interactive explorations and a mobile app that you can take with you wherever you are. If you are naturally curious, want to build your problem-solving skills, or need to develop confidence in your analytical abilities, then get Brilliant Premium to learn something new. Brilliant's thought-provoking math, science, and computer science content helps guide you to mastery by taking complex concepts and breaking them down into bite-sized, understandable chunks. You'll start by having fun with your interactive explorations. Over time, you'll be amazed at what you can accomplish. If you'd like to learn more science, math, and computer science, and want to do it at your own pace and from the comfort of your own home, go to brilliant.org/IsaacArthur and try it out for free. So this weekend we have a bonus episode coming out, the first installment of a new series, Becoming an Interplanetary Species, where we will look at the National Space Society's roadmap to the stars and see what the first steps are to us becoming an interplanetary species. Last week we looked at some truly enormous space habitats we might build in our future as an alternative to settling new planets, and next week we will take a look at how we can go about acquiring the vast amounts of raw materials we will need to construct millions of those continent-sized habitats, and ask if we should dismantle the solar system itself to provide them. After that, we'll be back to the Fermi Paradox series to consider disappearing stars and cosmic voids, to consider if such things are natural or might be signs of older alien civilizations dismantling their own solar systems or even entire galaxies. If you want to alert when those and other episodes come out, make sure to subscribe to the channel. And if you'd like to help support future episodes, you can donate to us on Patreon or our website, isaacarthur.net, which are linked in the episode description below, along with all of our various social media forums, where you can get updates and chat with others about the concepts in the episodes and many other futuristic ideas. Until next time, thanks for watching and have a great week.